Hello dear friends, in this video we will learn how to find complex roots of a biquadratic equation, right? In order to learn that, we must have to take a biquadratic equation. Let's have a biquadratic equation x to the power 4 plus a to the power 4 that is equal to 0. Now we have to find out the roots of this equation. That means we have to find out the values of x, right? In order to solve the values of x, I have already given a method in my previous videos. I will give that method's link in the description, but now in today's video I will give another method to solve this particular problem. To solve this problem, first we have to do what? We have to write it x square plus a square. So what I am trying to do, I am trying to make it a whole square of x square plus a square. In order to do that, I need to add 2 a square x square and subtract 2 x square a square equals to 0. By doing this, I have got a benefit. This x square plus a square 2a square x square, this is the whole square of x square plus a square's whole square, right? And next I am getting root 2 a x whole square that is equal to 0. In all, we can expand it by using the formula a square minus b square, that is a minus b, a plus b, right? Okay, so now use that formula in the particular expression. We will have x square plus a square minus root 2 ax along with x square plus a square plus under root 2 ax equal to 0. So either x square plus a square minus root 2 ax will be equal to 0, or the another one will be equal to 0. Okay, so first we will take this case. So in order to take this case, we have to compare it with the standard quadratic equation. That will be ax square plus bx plus c that is equal to 0, and I will use Sridharacharya rule. Sridharacharya rule. So Sridharacharya rule says the value of x will be equal to minus b plus minus under root b square minus 4ac upon 2a, right? So here the value of b is nothing but root 2a, so the value of b is under root 2a. Here you can see that, but that is minus under root 2a. So minus minus plus, plus minus under root b square, that means 2a square, right? Minus 4ac. The value of a is 1 here, and the value of c is a square. Minus 4a square divided by 2a, that means 2 multiplied by 1. So here we are having the value of x is root 2a by 2 plus minus here under root minus 2a square upon 2. Therefore the values of x will be a upon root 2 and plus minus I a upon under root 2. So these are the values of x using first expression, or now using second expression, x square plus a square plus root 2 ax equal to 0. The values of x will be, I will write these values directly because you can find out these values using the same procedure. Okay, so the values of x will be minus a upon under root 2 plus minus I a upon root 2, and these are the final 4 values of x, and these are required. These are required values of x, and this is our answer, right? So this is the method using the algebraic expressions. In previous video, I will give that video's link in the description. You can have the solution of this particular problem by using the trigonometric identities. Now let's move forward, and again we will have a very interesting problem in mathematics. We are having a biquadratic equation, that is px equals to x to the power 4 minus 4x cube plus 8x square minus 8x plus 4 equals to 0. So this is a biquadratic equation, and the problem to solve this equation, I name it as equation number 1. The problem to solve this equation, the constant number 4 can be factorized as plus minus 1 plus minus 2 plus minus 4, and none of these numbers, none of these satisfy equation 1. Then how to factorize this equation? This is the biggest question. Then how to factorize it? How to factorize it, or how to get the solution of 1? How to get solution of equation 1, right? So in order to find out its solution, we have to consider one of the factor of 4. Okay, so let x equal to 1. Okay, that means x minus 1 divides px or equation 1 and have a quotient and remainder Okay, so we will divide it by x minus 1. So let's divide it using x minus 1. So I will use beneath it now x minus 1, and the px is a x to the power 4 minus 4x cube plus 8x square minus 8x plus 4. So in order to divide it, what we need? We need to make it x to the power 4. In order to make this x to the power 4, we have to multiply it by x cube. So I will write here x cube, then I will get here x cube minus, sorry, x to the power 4 minus x cube. By applying divide rule, this will be minus, and this will be plus. This will be cut it out, and here the value will be minus 3x cube and plus 8x square. Now in order to make this minus 3x cube, we have to multiply it by minus 3x square. When we multiply it by minus 3x square, we will get minus 3x cube and then plus 3x square, again plus, and this is minus. It will be cut it out, and we will get 5x square. right? Now I will have minus 8x. So again, in order to divide it, I need to make it 5x square. We have to multiply this x minus 1 by 5x. So I will multiply it by 5x. Then I got it 5x square minus 5x. And again, this is minus and this is plus. It will be cut it out. Then I get minus 3x plus 4. And to make it, we have to multiply it again minus 3. So I will have the number minus 3x plus 3 and finally plus minus. It will cut it out and here we will have 1. Now using the remainder theorem, this was initially px. Here you can see this was px here. Okay, so px can be written as x minus 1 multiply x cube minus 3x square plus 5x minus 3 plus 1. That is called the remainder theorem of polynomials. The remainder theorem of polynomials says that the dividend that is equal to divisor multiplied by quotient plus remainder. Okay, that is a equal to bq plus r. This is the famous remainder theorem. Okay, where r is, that is between b. Okay, so now move forward. Here we get p. Now we have to factorize only this cubic equation, right? And make sure, and I keep in note. Okay, so I will keep it in note that this cubic equation, so I will drag a line here, this cubic equation definitely be factorized. Okay, so if this equation definitely be factorized, then x minus 1 will be its factor. How to check it? The procedure is again same. We have to check this constant 3. We have to check this constant 3. Its factor are plus minus 1 plus minus 3. So here x equal to 1 will satisfy this. How to check? The cube of 1 will be 1 minus 3, cube of 1 square will be 1 plus 5 and then minus 3. So minus 3 minus 3 minus 6, 5 plus 1 6. So here we see that x equal to 1 will satisfy this equation. Okay, that means x minus 1 is a factor of x cube minus 3x square plus 5x minus 3. Okay, so if x minus 1 is a factor of this equation, then it will divide it completely. X cube minus 3x square plus 5x minus 3. That means we have to multiply by x square to get x cube minus x square. Then we get here, will be cut it out. This will be sign plus, this will be minus, so minus 2x square plus 5x. Now we have to multiply by minus 2x to get it minus 2x square. So we will have minus 2x square plus 2x. Again it will be cut it out. So that is 3x and then minus 3. And we have to multiply by plus 3 and we get 3x minus 3, and this will be minus, this will be plus, entire will be 0. Now what we are seeing? We are seeing that this particular expression px, that was earlier written in the form of x minus 1 into x cube minus 3x square plus 5x minus 3 plus 1 now can be written as px equal to, okay, can be written as, I will write it here, okay. Now it can be written as px equal to x minus 1, right? And then what we are having, x minus 1 into x square minus 2x, x square minus 2x, and then plus 3, okay, plus 3. And here we are having one more, x minus 1, that was already present there. So x minus 1 and x minus 1, there will be x minus 1 to the power 2 and plus 1, that we don't have to forget, plus 1. Now we can write it x minus 1. So now we have to mention one thing, if there is x minus 1 outside, we have to make the x minus 1 inside also. So how can we make it? X square minus 2x plus 1 plus 2, the 3 can be broken out in this, and now we will have x minus 1 to the whole square, x minus 1 whole square, right? And next we are having x minus 1's whole square plus 2. Here friends, you can see that this term will be x minus 1 whole square plus 2 and plus 1. Now multiply x minus 1 inside, x minus 1 to the power 4, then plus 2 x minus 1 to the power 2 and plus 1. So this is our final expression. And in all, if we consider x minus 1 whole square as capital A, then we can get px equal to a to the power 4 plus 2 a square plus 1, and you can see that this is the a square plus 1's whole square. So that means this is the x square, this is the x minus 1's whole square plus 1's whole square, right? Because the value of a is x minus 1 and we have to put this value of a here, right? So now finally we will have x square plus x square minus 2x plus 2, x square minus 2x plus 2 whole square, okay. And now the factor of this will give you the values of x. So for the value of x, put px equal to 0, that means x square minus 2x plus 2 into x square minus 2x plus 2 equal to 0. That means by factorizing it using Sridharacharya rules, the value of x will be 1 plus minus I and 1 plus minus I, because I don't think it will be worthy to make a solution of this quadratic equation, because I have already used this the Sridharacharya rule or the formula previously 2 times, okay. So this is the procedure to solve this to solve the bi-quadratic equation which are having the complex roots. I just want to make you note one thing at the end. Note that in a bi-quadratic equation, all the roots can be complex, but in a cubic equation one root must be real and other two can be complex or may be complex. This is a very good point. You can have this point in your notice. So this was end from my side for this video. If you like the video, please like it, okay, and if you have any suggestions, please let me know so that I can improve myself, I can make videos better for all of you. And if you are really liking, then please like, share and subscribe the video. Thank you from my side. Take care. Bye bye.